every living organism today, me, you, the bacteria in my gut, the flies that are buzzing around my office, right? Every living organism around today evolved from the very first life on Earth, right? And the very first life on Earth that evolved billions of years ago set the stage for all the rest of life to evolve from that. Now, unfortunately, we don't have any unquestioned fossil evidence of the progression from non-living molecules to living organisms, right? When Earth first formed, life didn't exist. And we don't have fossil evidence of that transition from no life to life, which makes sense, right? Because the original life was single-celled, it was tiny, and it happened a really long time ago. So it's very unlikely for those tiny, tiny, tiny little organisms to be preserved and still be around today for us to find. So we don't have unquestioned fossil evidence of this occurring. However, we do have hypotheses for how it could have occurred. Our hypotheses come from what we know about life today, what life needs to survive today, how we might think about how all of these ingredients coming together based on the ingredients that existed in Earth's early history. Now, we know based on life today that life requires several elements, being carbon. We're carbon-based organisms. It needs hydrogen and oxygen and nitrogen and phosphorus and sulfur. We think without these elements, life cannot exist, right? Luckily, all of these elements are abundant on Earth, right? Now, in addition to all of these elements, you need other essential components of life. One is protein, right? These elements have to come together to make a protein. Proteins are like they're building materials. They act as catalysts that create chemical reactions within organisms. The second thing life needs is nucleic acids. These are what forms our RNA and DNA that allows us to replicate our genetic code and reproduce and develop and function. Life also needs organic phosphorus compounds, and these are what allow photosynthetic life to transform light energy into energy, right, that the organism can actually use. And then finally, you need a container. Not only do all of these things have to exist, you have to have proteins and nucleic acids and organic phosphorus compounds, you have to have a container that brings all of these materials together, right? Some sort of enclosing cell membrane to keep all these components together and intact. Now, we don't know how or exactly where all of these ingredients came together to form life. However, we do have some hypotheses for places that it could have occurred. One of them being mid-ocean ridges. Remember that mid-ocean ridges are areas in the ocean where new material is welling up from the mantle, spewing out onto the ocean floor through undersea volcanoes, creating new oceanic lithosphere, new ocean floor. And scientists think that all of the ingredients that life needs to form could have existed at mid-ocean ridges long ago in the past, right? Now we are able to go down to mid-ocean ridges by diving in submersibles, by sending down instruments that can collect samples for us. And we have learned that down here, it's completely dark. It's great depth, so great pressure, and there's jets of scalding hot water rising out of what we call hydrothermal vents and volcanic chimneys. Now, these hot waters dissolve an abundance of elements that are vital to life, right? So these really hot water jets could have been bringing the essential elements from deep within Earth to the surface of the Earth. Now, clays also exist along these ridges, and that provides templates that are needed to construct the organic molecules that preceded life, right? So elements are being brought up from the mantle, and clays around these mid-ocean ridges are also providing ingredients. So we think mid-ocean ridges might have been the location where life first formed because that's where all of the ingredients came together. Now, at these mid-ocean ridges, I said that these ingredients and this really hot water is coming out of hydrothermal vents. These vents are huge, they're monstrous. So here I've shown you an image of these hydrothermal vents. They're basically chimneys that are allowing this hot water and all of the compounds within it to spew out of the ocean floor. And they can be the size of skyscrapers, right? They could be 40, 50 meters tall. They're huge. And they might have been the place where life evolved. Notice I said might. there are other places that life could have also evolved, right? Scientists have found clues deep underground. They've also found clues in comets. Maybe life formed elsewhere and then was brought to Earth on a comet. Right? Life might have even been able to evolve within the atmosphere. So there's lots of different ideas, but hydrothermal vents are a prominent hypothesis right now. Not yet a theory, still a hypothesis. Now the question is, at these hydrothermal vents, as I said, it's total darkness down there, right? There's no way for sunlight to penetrate to these great depths. So without light for photosynthesis, how did the first organisms get energy, right? How does that make sense? Well, we think that they were able to get energy through chemosynthesis. So rather than photosynthesis that requires light, these organisms might have used chemosynthesis that just requires other chemicals. Right? And modern organisms can do this, right? Modern life exists on these hydrothermal vents. As you can see in this image, right? It's just covered in life. So modern organisms that can live in such extreme temperatures are called hyperthermophiles, literally meaning heat lovers. And in the absence of light for photosynthesis, these organisms today get their energy from chemosynthesis. So they get energy by oxidizing inorganic substances like hydrogen sulfide. So we think maybe this is where life originated on Earth in the past. Again, hypothesis, not yet a theory.